Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students' office at the University of East Anglia. This webcast is part of the Steps into Algebra series and concerns multiplying and dividing algebraic fractions. This guide describes how to multiply and divide algebraic fractions. Introduction. An algebraic fraction is a piece of mathematics which includes a dividing line and one or more unknowns or variables. You may think of algebraic fractions as being similar to numerical fractions, but the numerator and or denominator comprise algebraic expressions instead of just numbers. Some examples are x divided by 2, 3 divided by 2 minus x, t plus 2 divided by x plus y squared. It is extremely common in algebra for you to have to manipulate algebraic fractions in some way. This is useful as combining more than one algebraic fraction into a single fraction is beneficial when manipulating equations and expressions. This is usually achieved by the four basic functions of arithmetic: adding, subtracting, multiplying and dividing. The methods for adding, subtracting, multiplying and dividing algebraic fractions are the same as those for numerical fractions. Therefore, if you need to know how to multiply and divide algebraic fractions, it's important that you understand how to multiply and divide numerical fractions. To help you, read the study guide, Multiplying and Dividing Fractions. Multiplying algebraic fractions. When multiplying numerical fractions, you multiply the numerators to find the numerator of the answer and multiply the denominators to find the denominator of the answer. You should then cancel down the result if possible. See the study guide, Cancelling Down Fractions, if you find this difficult. For example, 3/8 multiplied by 2/5 equals 3 multiplied by 2 divided by 8 multiplied by 5, which equals 6 divided by 40, which cancels down to give 3/20. The method for multiplying algebraic fractions is identical. That is, you multiply the numerators of the fractions to find the numerator of the answer and multiply the denominators of the fractions to find the denominator of the answer. You can use the Snalphabet system to help you perform the multiplications. See the study guide, Snalphabet. When you have done this, you should cancel down your result if necessary. To cancel down the algebraic fraction, you need to factorise both the numerator and denominator and write them in factored form. See study guides, Simple Factorisation and Factorising Quadratic Expressions. When you have the numerator and the denominator in factored form, you cancel down identical factors to give the simplified form of the algebraic fraction. For example, what is s divided by 2 multiplied by 3t divided by s squared? Multiplying the numerators together gives 3st, and multiplying the denominators together gives 2s squared. So, s divided by 2 multiplied by 3t divided by s squared equals 3st divided by 2s squared. Writing in factored form, 3st divided by 2s squared equals 3 times s times t divided by 2 times s, and cancelling the common factor of s gives the simplified form of the algebraic fraction 3t divided by 2s. Let's look at another example. What is 3 divided by 4q minus 8 multiplied by q minus 2 divided by q plus 1? When you have numerators or denominators containing addition or subtraction, such as q plus 1 and 4q minus 8 in the example, it is helpful to put them in brackets before multiplying. So the question can be rewritten as 3 divided by 4q minus 8 in brackets multiplied by q minus 2 in brackets divided by q plus 1 in brackets. Multiplying the numerators gives 3 multiplied by q minus 2 in brackets, and multiplying the denominators gives 4q minus 8 in brackets multiplied by q plus 1 in brackets. The terms in the first bracket in the denominator have a common factor of 4, and so can be factorised to give 4 multiplied by q minus 2 in brackets. So after performing the multiplication you get 3 divided by 4q minus 8 in brackets multiplied by q minus 2 divided by q plus 1 equals 3 multiplied by q minus 2 in brackets all divided by 4 multiplied by q minus 2 in brackets multiplied by q plus 1 in brackets. There is a common factor of q minus 2 which can be cancelled down to leave the simplified answer. 3 divided by 4 times q plus 1 in brackets.
Brilliant.
Let's look at a more complicated example. Simplify x plus 5 divided by x plus 3 multiplied by x squared plus 4x plus 3 divided by x squared plus 9x plus 20. In this example, quadratic expressions make up the numerator and denominator of the second fraction. The numerator, x squared plus 4x plus 3, can be factorised to give x plus 1 in brackets multiplied by x plus 3 in brackets. And the denominator, x squared plus 9x plus 20, can be factorised to give x plus 5 in brackets multiplied by x plus 4 in brackets. So, after introducing brackets and factorising the quadratic expressions, x plus 5 divided by x plus 3 multiplied by x squared plus 4x plus 3 divided by x squared plus 9x plus 20 equals x plus 5 in brackets divided by x plus 3 in brackets multiplied by x plus 1 in brackets multiplied by x plus 3 in brackets all divided by x plus 5 in brackets multiplied by x plus 4 in brackets, which equals x plus 5 in brackets multiplied by x plus 1 in brackets multiplied by x plus 3 in brackets, all divided by x plus 3 in brackets multiplied by x plus 5 in brackets multiplied by x plus 4 in brackets. There are common factors of x plus 3 and x plus 5 which can be cancelled down to give x plus 1 divided by x plus 4. Division of algebraic fractions. As with multiplying algebraic fractions, the method for dividing algebraic fractions is identical to that for dividing numerical fractions. Specifically, you take the reciprocal of the second fraction, in other words, turn it upside down, and then multiply the algebraic fractions together instead of dividing them. You should then simplify your answer by cancelling down if possible. Here is an example. Write xy over 3 divided by y squared over 9x in its simplest form. Inverting the second fraction and multiplying instead gives xy over 3 divided by y squared over 9x equals xy over 3 multiplied by 9x over y squared. After performing the multiplication, xy over 3 multiplied by 9x over y squared equals 9x squared y over 3y squared. The numerator and denominator can be written in factored form, which is 3 multiplied by 3 multiplied by x multiplied by x multiplied by y, all divided by 3 multiplied by y multiplied by y. You have a common factor of 3y, which can be cancelled down to give 3x squared over y. Right. Here is another example. What is 2a over a plus 3b divided by 4a squared over b? Here it is useful to begin by putting the denominator of the first fraction in brackets. Now you invert the second fraction and multiply to give 2a over a plus 3b in brackets multiplied by b over 4a squared, which equals 2ab divided by 4a squared multiplied by a plus 3b in brackets. After writing the algebraic fraction in factored form, 2ab over 4a squared multiplied by a plus 3b in brackets equals 2 multiplied by a multiplied by b divided by 2 multiplied by 2 multiplied by a multiplied by a multiplied by a plus 3b in brackets. You can see that there is a common factor of 2a. This can be cancelled down to give the simplified form. b divided by 2a multiplied by a plus 3b in brackets. Further guidance and information. If you have any further questions about algebra or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592 761 or email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.